In this video we're going to be investigating how we calculate stationary points. Now we've been given a function here. We have y is equal to 2x cubed plus 3x squared minus 12x plus 7, and we're going to find the stationary points of this function. Now stationary points occur when the gradient is equal to 0. And when we're dealing with a curve like we have here, the gradient is given by dy by dx. So to find the stationary points, we have to calculate dy by dx and set it equal to 0. This is how we find stationary points of a function. So what do we need to do? Well, the first thing we need to find is dy by dx. We need to differentiate our function. So let's differentiate this function here. So dy by dx is equal to, well, we need to differentiate 2x cubed first of all. So how do we differentiate this? Well, we bring the power down the front, so we'll get 2 times 3, which is 6. And then we take 1 off the power, so 3 minus 1 is 2, so that will leave us with a 6x squared. Looking at the next term, we have 3x squared, so how do we differentiate that? Well, we do the same as we did for this one. We bring the power down the front, so we'll have 3 times 2, which is 6. Take 1 off the power, so 2 minus 1 is 1, so we'll have that as 6x. You could write in x to the power of 1, but we don't normally do that, so we'll just leave it as 6x. Now, looking at this next term, we have minus 12x. Now, when we differentiate x, so if we just forget about that minus 12 for now, when we differentiate x, we just get 1. So this leaves us with minus 12 times 1, which is just minus 12. And then when we differentiate a constant, so 7 is just a constant, when we differentiate a constant we get 0. So we could put in a plus 0 at the end here, but it doesn't add anything, so we'll just leave that out. So we can say that dy by dx is equal to 6x squared plus 6x minus 12. We have dy by dx now, so to find the stationary point we just need to set that equal to 0. So we'll have 6x squared plus 6x minus 12 is equal to 0. To find the stationary point we just need to solve this equation now, solve it for x. Now this is a quadratic and there's lots of different ways of solving a quadratic. I'm going to factorise it. And the first thing you can see is there is a common factor of 6 in every term. So the first thing I'm going to do is bring out that common factor of 6. So I'll have 6 out the front, and then within the bracket we'll have x squared plus x minus 2, and all of that is equal to 0. Now I need to factorise this x squared plus x minus 2. Now, to factorise a quadratic, we're looking for 2 numbers that multiply to give us minus 2 and add to give us a coefficient of x, so that's 1. So 2 numbers that multiply to give us minus 2 and that add to give us 1, well that would be 2 and minus 1. Okay, because we can see 2 times minus 1 is minus 2, and 2 plus minus 1 gives us 1. So that one's done. So, using our 2 and our minus 1, we can rewrite our quadratic as x plus 2, x minus 1, all equal to 0. And we can see the 2 values of x that solve this equation. It's when this bracket here is equal to 0, which is when x is minus 2. And it is when this bracket is equal to 0, which is when x is equal to 1. So what we found are our 2 x values of our stationary points, but your stationary points are a coordinate, so you also need the corresponding y value. So what we should do, we take each of our x values and substitute them back into the original equation. Some students get tempted to sub it back into dy by dx. That's not what we do. We take each point and sub it back into the original, the one that has y equal to. So I'm going to take x equals 1, and I'm going to substitute it into the original. So we'll have y is equal to 2 lots of 1 cubed plus 3 lots of 1 squared minus 12 lots of 1, and then a plus 7. And if you work all that out, we'll get that y is equal to 0. So my first stationary point is at 1, 0. That's the coordinate of my first stationary point. If I look at the other value of x to get my second stationary point when x is equal to minus 2, again I'm going to sub minus 2 back into the original function. I'll get y is equal to 2 lots of minus 2 cubed plus 3 lots of minus 2 squared minus 12 lots of minus 2 and plus 7 at the end. And when we work all of those out, we'll get 27. So we have the y coordinate, so we can write down our point. It's going to be minus 2, 27. So we found the 2 stationary points of this function here. It is 1, 0 and minus 2, 27. And the big point to take away from this is when you're finding stationary points, you need to find dy by dx, or whatever the letters are. It could be df by dx or dg by dt, and set it equal to 0. And then solve that equation to get your stationary points. Thank you for watching.